Can AI actually read your mind? Well, the short answer is no, but the long answer is way more interesting. You see, it depends on AI's ability to get the stuff that you mean but don't say. And that is called implicit intent. So, for example, if you say, I guess that works, but you have a frown on your face, in that case, your words say yes, your face says no, and your voice probably says maybe. And this is like a really important problem that we don't hear talked about a lot in the AI space. And it depends on something called theory of mind. So now, as humans, we kind of develop theory of mind naturally through a process of self-awareness and emotional maturity. You get pretty good at putting yourself in the shoes of others, so to speak. So how do we give AI theory of mind, right? Well, there's a way that we're doing it currently with our models. One is text and context. This is the standard context window. You're talking to ChatGPT or you're talking to Gemini, and it has some kind of memory of everything you've been talking about for the last X tokens, because it does have like a constraint, which is the context window. So once that fills up, it's either going to truncate the context, so just like kind of like a sliding window where it looks at the last X amount of the conversation, or it's going to do something called context compaction. This was, I think, first done by Anthropic, and now it's become popular. I've seen it even in Codex, where like once the context fills up, it takes the context and then summarizes it, compacts it basically, and then hands over that summary as part of the context for another AI model to take over and talk to you. So the problem with that is that there's like a few things. First, there's the lost in the middle phenomenon, where it's like if the context is long, AI tends to remember the first and the last bits, and then whatever's in the middle essentially gets lost. Another one is that it's pretty lossy. So if you're doing truncation, where you're having a sliding window thing, then it's not remembering parts of the older conversation that might be relevant. And if you're doing context compaction, well, the summary is not going to be as detailed as the actual thing. So there's some loss happening. Sometimes it's even with the architecture of the LLM itself. Maybe it's just not paying attention to the parts that it should, and it's paying attention to parts that it shouldn't. So this is really good in terms of efficiency, but it gets lossy when you scale it up. Another way is user embeddings. This probably happens to you already, like when you're using Google AI during search and stuff. Some of the websites out there using AI will track things like your clicks, how long you've stayed in a place, the queries you've used before, etc., etc. And it's going to turn those, or tokenize them and embed them, or calculate embeddings, which is turn them into vectors that an AI can understand. So the AI has this sort of metadata of everything else you've been doing outside of your direct conversation with it. And this gives like behavioral signals, right? That's the user embeddings approach. Now, it's pretty good and it gives a lot more information, but just like the third thing that we're looking at, one of the problems it has is it doesn't scale very well. First of all, there's just like a ton of data you can collect as far as behavior is concerned. And you barely know what's important and what's not, and it's very hard to scale that over millions or billions of users. So this one doesn't scale very well. Let's just say that, doesn't scale very well. The third thing, which is a little more modern and quite frankly a little scary, is multimodal fusion. In this case, the AI is using what you're saying, how you're saying it, the audio, and what the look on your face and your body language is, the video. You're seeing this in robotics, you're seeing this in some AI applications. Like, what was that thing? I think there was like an AI model that could be used to screen applicants, like you do interviews in the AI model. So it's also using the video feed, right? And multimodal fusion is probably like the most accurate thing we have right now. But of course, for one, it has the same kind of scaling problem as the other one, just because of the heaviness of the data it's collecting. And for another, there might be ethical concerns, like do you want ChatGPT to see your facial expressions while you're talking to it? I don't know. But that's another thing. So this one also has a scaling issue, but it's wildly effective. Wildly effective, right? We know that no current models currently solve the whole problem of theory of mind. but they have found some interesting results. A September 2025 study showed that GPT-4 could predict which images. What was that little fact again? It showed that GPT-4 could predict which images people would like. GPT-4 could predict emotions, sorry, from video with accuracy matching what humans could do. So this is GPT-4. We're not even looking at frontier models at this point. We're just looking at some of the older models we have, right? And crucially, the structure of its emotion ratings converge with human patterns. Now, combine that with some other stuff that we're going to look at, like persistent memory, and you don't just have a chatbot anymore. You have a companion who remembers everything about you from your past, however many months or potentially years of talking to each other. And that's really powerful. Now, there's two reasons why people think that at the moment we have this kind of gap that we're trying to solve with the theory of mind thing. There's a more optimistic theory, which is called representational convergence. And what that means is that some people think that if you, and this has been shown by the research, if you look at all the models, the way they represent human concepts in like their internal model is kind of converging. They tend to represent the same concepts in the same places in their representational space. And this seems to not even depend on the architecture of the neural network underneath. So I don't know if you can see this in diffusion models, but I know across LLMs, despite their implementation, you do see this kind of convergence in the way they represent concepts. I'm thinking we might see in diffusion models as well. For those who don't know what a diffusion model is, it's like an alternative to the transformer architecture that your LLMs use, and it's being used in a lot of places. Your chatbot uses an LLM, but the weather prediction AIs, the protein folding AIs, they're using diffusion models. It's an entirely different kind of architecture. I might talk about it in a future video. But for now, just know that we're seeing representational convergence. And the people who believe this think that over time, as the AIs get smarter, they will have such an accurate model of human concepts that they will be able to read our minds practically. So they think that this is coming. The other one is a little more pessimistic. And I like the word that my producer uses. It's called a stochastic parrot. So like when a parrot says things to you, it doesn't necessarily know what those things mean. It's just making noises. And you know what it means. And sometimes maybe the parrot can match a pattern. Like every time he's angry, he says damn or whatever. And so like maybe, or if it's hurt, he says X or Y. And maybe you go and you try and drive a nail through a board of wood and the parrot is there and you nail your thumb or smack your thumb with the hammer and the parrot goes damn. And it's like, doesn't know what damn means, but he knows that's what you say when you're hurt or when you're angry, or it's like a curse word that you use. In that case, the parrot doesn't necessarily understand the meaning of the word, but it can pattern match well enough to kind of make you think that it understands the meaning of the word. So the idea behind stochastic parrots is that LLMs are just collecting things we call bags of heuristics. These are like, this is based on a theory basically by this guy, Spiegel, what's his name? Benjamin Spiegel, right? So it's like they're collecting bags of heuristics, and what they're doing is they've gotten really good at training, like fitting the training data, but they haven't really grokked. They haven't really got the underlying concept. They haven't really understood it in a way that they can generalize in the wild. Now, there's a lot of stuff around this and how to make AIs better at that. For example, there's like different approaches. So like RL instead of RLHF. So with RLHF, that's reinforcement learning with human feedback. When you're training AI, you're basically grading its outputs to teach it what a human would prefer. But with RL, the AI is playing with itself. Like this is how AlphaGo and AlphaZero were developed. Basically play with itself and explore its own ideas and have some kind of feedback loop until it gets better. And people are seeing that RL is actually really, really powerful, and RLHF might not necessarily be the way to go. So that's one way to get past the stochastic parrots thing about making LLMs or AIs actually understand concepts instead of just pattern match. But there are other things. And anyway, if an LLM or whatever is learning by playing with itself, can we really say it understands humans after that? Or is it just operating in a different dimension? It's like playing chess with stockfish. This thing isn't even thinking like you. It's not necessarily seeing all the particular patterns that you're used to. It's just calculating or whatever. And it's done really good at that. So, what could change things? How can we improve the theory of mind for AI? Well, one thing is persistent memory. We have this problem with context, and it's a problem that everybody's thinking about how to solve. How can you maintain context and an LLM understands the context, it doesn't forget, it doesn't get reset, etc. Once we figure out persistent memory, and we're getting much better at this over and over again, or like over time, then the AI is going to have a lot of information about your process, which can help you predict how you will behave in the future or what you might actually want, right? Another one is multimodal depth. This is just a continuation of the multimodal fusion. The more different modalities we include in the input to the AI, like video, audio, text, behavioral signals, etc., the better the AI gets at understanding intent, because each of these modalities carries meaning. And finally, we have preference prediction, which is basically as AI gets better and better at understanding us, it'll be able to predict our preferences. So this is where an AI has your context from the last X months or X years of interacting with you, and just kind of understands when you say something that feels or sounds ambiguous, what you actually mean. Now, the trap of that is that it might feel like real empathy, but don't forget that you might actually be dealing with something that's just a stochastic parrot under the hood. And that's an interesting time. I don't know what philosophical or ethical implications that's going to have, but it's definitely going to be an interesting thing to see. So yeah, theory of mind, implicit intent, and AI reading your mind. That's an interesting research topic I'm seeing around, and it's probably something worth to consider or experiment with, especially if you're building with AI. How can you make it much better at that? Anyway, that's pretty much it.